Hello and welcome everyone. This is Noah, and in this video we are going to look at graphing quadratic functions that have a special form. Alright, for our examples we're going to find, for the following functions, we're going to find the y-intercept, the y-intercept's mirror, the x-intercepts, the vertex, and two additional points, and use that information to graph the function. The first function we're going to look at for part A is f of x equals 4x squared minus 9. We want to start by finding the vertex to this. Actually, let's see. Let's go ahead and find the vertex on this one to start, and then we're going to see something about it that we'll use for the next example. So the x value of the vertex is going to be negative b over 2a, but b is 0. If we look at this, a equals 4, c equals negative 9, b equals 0, because there's no x term. This is 4x squared plus 0x's minus 9. So our b value is 0, so the x value of the vertex is 0. If we plug that into the function, f of 0, we get negative 9. But this is also, so the point 0 comma negative 9 is the vertex and the y-intercept. So this vertex is both the y-intercept and the vertex. This vertex point is also the y-intercept. Since the vertex is the y-intercept, it's also the mirror point for it. So that one point is going to be all three of these. Let's go ahead and take a look at what this looks like on the graph. Draw my y-axis here. And this is a negative 9, so let's my x-axis up a little bit higher. 4, negative 4, 3, negative 8. And so that point 0, negative 9 is down here. The leading coefficient is positive, so this is going to be upward facing. Let's go ahead and find the x-intercepts to see where those go. We go 0 equals 4x squared minus 9. This is nice because it's a difference of squares, so it factors as 2x minus 3 times 2x plus 3. So solving for x, we should get x equals, well, let's do this out here. 2x minus 3 equals 0, or 2x plus 3 equals 0. If we solve for x, we get x equals 3 halves, or x equals negative 3 halves. So the x-intercepts are the points 3 halves, comma 0, and negative 3 halves, comma 0. So if those are my x-intercepts, I'm going to make my x scale by at least 1/2. Let's actually do 1 and 2 here. So 3 halves is 1.5. And negative 3 halves is negative 1.5 over here. So negative 3 halves, comma 0, and positive 3 halves, comma 0. And it does say to find two additional points. Let's find symmetrical points for us. Let's maybe plug in negative 1 and positive 1. If I were to make a table of values, do it horizontally here. If I have x and y, so far we've got negative 3 halves, 0, and then we want to get another point in there at negative 1. Then our vertex point is 0, negative 9. Then we want that symmetrical point when x is positive 1, and then we have when x is positive 3/2, y is 0. So if I say, what's f of 1? This will be 4 times 1 squared minus 9 equals -5. And that should work for both of these points due to the symmetry here around the vertex. So at 1, -5, we can plot that point, and at -1, -5, oops, -5. Both of these. And now we have 5 points and can draw a nice graph for this upward-facing parabola. Trying to get a nice smooth line through all 5 of my points. I'll label the function y equals f of x. And we're good. That is the graph that we are looking for. Okay, so what we're seeing with this is that with this symmetry, the vertex is the y-intercept and its mirror. So that is a nice little shortcut there. We realize that with these nice differences of squares, with that b value of 0, the x value of the vertex is 0, and so that is also going to give us the y-intercept and its mirror. And so you'll end up using that in the now you try problem. However, part B here gives us a problem that's a little different. It's x squared plus 8x plus 16. This is a perfect square trinomial is what we call this. And the b value is not 0. So we're not going to have quite that same nice thing happen to us, but some other nice things happen with this special form for a quadratic. So let's take a look and see what happens. We can start with the vertex. The x value of the vertex is going to be -8 over 2 times 1, so that's a -4. If we plug that in, g of -4 equals -4 squared plus 8 times -4 plus 16. So will give us 16 minus 8 times 4. That's 8 times 2 is 16, times 2 again is 32. So minus 32 plus 16. This equals 0. So in this case, the vertex ends up having a y value of 0. So the vertex is at -4, 0. So this is the vertex and an x-intercept. Okay. Well, if that's one of the x-intercepts, let's find the other one to start here. So if I look for that, I'll have 0 equals x squared plus 8x plus 16. And if we factor this, we have an x squared, so I need an x and an x here. With that 16, I kind of want to try a 4 and a 4. If I put plus and plus, those do add to 8. So that is the correct factorization. But this gives us x plus 4 equals 0, or x plus 4 equals 0. And so we only get x equals -4 out of both of these. So we only have the one x-intercept of -4, 0 that we just found. Let's go ahead and graph that, and then we'll look for the y-intercept and make a table and stuff here in a second. Get my y-axis. That's a -4. I'm going to move this to the right. It's upward facing. We go to -4, 0. Plot that point, and that's really all we have so far. let's go ahead and find the y-intercept. We'll get g of 0 equals 16. That means I want to go and maybe make this a 16 right here. So this is 8, so we're going by 2's in the vertical direction. Its mirror is then going to be on the other side of the vertex, so back at -8, right? Go 8 up to 16 and plot that point, -8, comma 16. You have that point 0, comma 16, so these are symmetrical. So the mirror point is -8, 16. And then I think we might want to have, like, if x is -6 or -2 in there. So if I plug in g of -2, we'll get -2 squared plus 8 times -2 plus 16. This equals 4 minus 16 plus 16 equals 4. So -2, 4, and -6, 4 are symmetrical. So those should have the same y value, -6, 4, and -2, 4. Cool, we've got 5 points. We can go ahead and draw our parabola now. And this is just, both of these we saw, these special forms give us special cases where, in the difference of squares example that we saw above, the vertex was the y-intercept, and where we have a perfect video if you need to, but kind of the same process we had before, but we've got these special factorizations that we run into for these problems. All right, thanks so much for watching. Go ahead and give the Now You Try problems a go, and in the next video we'll walk through those solutions for you.